My name is Telib. I work for OptimaD Engineering from Italy. And with this talk, I would like to give a rather, let's say, our vision with regards of CFD and automatic shape optimization, and how this technology should interact with HPC and cloud-based software as a service. So a small outline about the talk. I spend 2 words on our company. I'll talk about simulations. I'll talk about optimization, and then give some concluding remarks. So OptimaD is actually a spin-off of the Politecnico di Torino of the Department of Aerospace Engineering. We're a small company. We're 12 persons, but it's particular in the sense that all of these 12 persons hold a PhD in scientific computing, fluid mechanics, and things like that. And the key technology that we develop in terms of scientific computing are, the first thing is for sure an immersed boundary solver, which is another paradigm of dealing with geometry in simulations, adjoint methods and optimization techniques. And also, we have a big commitment to computational geometry, which goes into the direction of what Marco already presented. Just one slide for whom we're working. So you see, we work mainly for large companies. And we'll see that this is not that this is an intrinsic problem of what we're doing. That shape optimization rarely is done by small companies. So we work for the aerospace companies, we work for Boeing, for Airbus, for the Italian one, Thales Alenia Space, for the automotive industry. And then we're involved in publicly funded research, from FP7 to Horizon 2020 in price shape, and also we develop things for the Italian Space Agency. Okay. So in this first part now, I would like to really talk about aerodynamic analysis and CFD and how our vision on it. So if we talk on aerodynamic analysis, we have to talk firstly about CFD codes. So, I mean, you see it every day. CFD codes nowadays, they have a huge potential about multi-physics, chemical reactions, moving bodies, and things like that. So there's no doubt about the potential of CFD and its potential impact. But in our opinion, until now, CFD is really far from being a one-click solution to anybody. Because, you see, one of the biggest problems which we encounter is, of course, turbulence. 95% of flows are turbulent and are separated, except for very rare cases. In these cases, the turbulence model, which is inside the simulation, has a very large margin of uncertainty. What we saw also often is that very simple best practices came out of vogue in the last 10 years. For example, in order to be sure that a CFD simulation, that you can trust this CFD simulation, you should be in what is called the asymptotic region of grid convergence. That means you should refine the grid, and you should see that the quantities that you observe, they should follow a certain trend. If not, you cannot trust in any way your CFD simulations. But no one does this anymore. And we believe also that this is motivated by a counterproductive message which comes from research and from, I must say so, also from ISVs like us. Because in order to sell, they say, okay, it works, everything works. And we know it is not true. I want to say a small comment on that. When I was invited at Boeing, the head of research at Boeing told us that between the end of the 90s and the beginning of the years 2000, they would reduce drastically the finance for CFD support. Boeing has its own CFD code since 40, 50 years. And why did they do so? Because their independent observers would go to conferences, would see people who claim that everything was possible, that everything was working. And so they stated that the maturity of technology was such that it didn't need any investment. So Boeing, at the beginning of the year 2000, stopped investing in CFD. Then, of course, engineers said, no, it's a big panic. Why don't you invest in CFD anymore? But this is, I think, a problem of communication and of honesty. And then, regarding to our, let's say, what we're focusing on in cloud, HPC, a key aspect is that the workflow that nowadays most of the CFD software has is originated in the 80s, and it was designed for workstations. So actually, the entire workflow, it is optimized itself in order to have the maximum throughput from your hardware. You have a limited hardware, and the workflow is such that with this given limited hardware, you get the maximum throughput. So, for example, this implies a massive interaction with the user, especially in the pre-processing phase. The user has to port these, he has to take the CAD model and port it into the simulation. And there he has to decide a lot of things. He has to defeature the model, has to decide which details should be maintained, which should not be maintained. It's a very critical step. And then afterwards, they invested in order to scale up to HPC. So, you see, considering all this, in our opinion, it takes an expertise. It takes expertise to run CFD. Because you have to balance mainly two things. You have to balance the accuracy that you want, and generally you don't even know the accuracy that you want, together with the uncertainty that for sure that you have in the results, and you don't know how much it is. So it is a very tricky task. And I mean, it's at the end an expert who will give a verdict about the reliability about the simulations. And sometimes it is, I skip this. So for example, this is a state-of-the-art simulation. This is a detached eddy simulation around a rotating wind turbine with fluid structure interaction. This simulation, it has actually, it has more than 1 billion grid points. You see, the errors, we have the experimental data. This is, trust me, this is really at the edge of what you can do nowadays. Errors with respect to experimental data are of order of 25%. So, in order to deliver HPC services, software as a service, in our opinion, we really have to look at to whom we want to deliver these services. And so, if you want to differentiate the CFD community, there are the ones, let's say, the first part of the group, which we call super experts, which are maybe even developers of CFD codes. These are persons who know exactly about the effect of numerical methods. They have data in order to quantify errors and uncertainty, which not all of us have. They have their own HPC resources. They have maybe in-house codes, and they have very sensitive data. So, you see, to these people it is difficult to sell something. Then there, let's say, experts. CFD consultants, people, they have the experience to set a model, to use it. They often can evaluate the results, and they may judge from the results if there's a critical aspect within the simulation. When you look at the resources that they maybe have a small HPC cluster or workstation in the house, and they have some code either with limited licenses, or also there's the big advent of, let's say, of the open source codes. And then they're really inexperienced users. Let's, for example, say a civil engineer. He doesn't know anything about CFD. In order to use CFD, for sure he needs someone who sets the model. For sure, this is someone also who cannot question the results. He'll get the results and he will stick to this. We cannot say anything about his computing environment, but for sure he hasn't access to the software. So if we analyze this, we say, to our opinion, the first category is not suited for what we want to do in Fortissimo, or generally in Fortissimo, or in very rare cases. But the other two, yes. Yeah? And you see, we'll see in the next two slides how we believe Fortissimo can interact with these users. So first of all, the experts. Okay. We saw that these experts, they have limited computing resources, they have limited licenses, and sometimes they are obliged to use, let's say, less accurate models due to these limitations. So, of course, the first potential is to use more accurate models to reduce uncertainty by employing HPC resources. This is what we call it's the complexification of the model. We do something more complicated, something more costly in order to move further. And of course, Fortissimo can be the right place for this to happen. But we see also that there's a conflict, because these persons for sure have their own HPC. They have their small resources in-house. And they'll try everything in order to saturate these resources. Because these resources that they have in-house, licenses and hardware, they are amortization cost. Whereas Fortissimo, this will be a real cost. It will be cash flow. So we think that there's a conflict, and we could work on this conflict. And then there's also something which we personally do not like, that there is this net difference between the in-house, what we do in-house and what we do in cloud. So if I develop something in-house, then afterwards I have to port it to the cloud and things like that. So what we would like to see is that within the Fortissimo, that HPC becomes, let's say, the native way of working for these persons. That they move away from the workstations that they have in-house, and they move natively to HPC. Of course, the business model needs to be defined. For the inexperienced users, things are very different to our opinion. Okay, you see, everything needs to be done for them. And so the first idea is to create very vertical applications, similar to what our colleagues from Icon CFD propose, which they can access and set everything automatically. But we also believe that it is realistic, that this is not really realistic. Because, you see, the workflow doesn't permit that nowadays. For example, if I was an architect and I want to do the aerodynamic loads of a building, I have to do what is called the defeaturing of the building in order to use a canonical workflow. And this is something he doesn't know how to do it. And as we discussed yesterday, even the results, it is for them often critical to interpret. So what we think, what is really realistic, is to keep the experts in the loop. I mean, this was one of the models Fortissimo is actually proposing. But in our opinion, this it's not an option. It is mandatory. So what we think, which is a little bit a part of Fortissimo, it's that there is a much bigger potential for HPC and clouds. But we believe that really the software needs to be changed. That you cannot build this on canonical CFD software. You have to different paradigms of coding should be applied. So one thing is what we call dynamic runtime adaptivity, and that is that the HPC resources should be employed not to scale up, but to reduce uncertainty in the model by adapting everything which needs to be adapted. That is the numerical grid, the models that I use. If I have separated flows, it should automatically switch from runs to large AD simulation or something like that. Numerical methods during the simulation. This would have as a big impact to transfer complexity, which now is dealt by the users to the machines. I want to give you two examples of what you can, if you rethink the software, what kind of simulations you can do. Okay, this is not for manufacturing SMEs. This is a demonstration of technology. So in this solver, you see, it is a fluid structure interaction. It is the auto-propulsion of a fish, where you see there is no mesh. There's no mesh morphing. There's no integration between different solvers. It is a carefully designed simulation platform which enables this kind of simulation. Even in getting the geometry into this simulation, this geometry, we were starting from 3 photos by a fish bought in the supermarket. Another type of application is this one. This is okay. This is a military application. It is the impact of a steel bullet on a steel plate. Generally speaking, in order to do this, if you would like to set up this kind of simulation in a canonical workflow, you could get crazy to do all the interaction between the fluid and the structure, the acoustic parts. But again, if you do with a different kind of software, with a different kind of paradigm, it becomes easy. So this was about simulations. I want to spend 2 words, 5 minutes, again on optimization, because this is what we're going to do within Fortissimo. So you see, when we talk about aerodynamic shape optimization, it is, you see, it will be, the message is very similar to what we said regarding CFD. Again, there's a big potential. You can have aerodynamic shape optimization can help you to get a better product and help you also to differentiate your product. But in order to do it, it is very complicated and it is very expensive. First of all, in order to set up the models, it takes a CFD expert. So it takes a CFD expert. But then it takes another expert to set up the whole optimization strategy, to set up the strategy, all the constraints that you have, which are the parameters which are important. So again, there's more complexity inside. You have to come up with a fault-safe workflow. That means everything should be automatized. You need, generally speaking, large computing resources. For example, for Lamborghini, when we do one optimization run, we consume of the order of 200,000 CPU hours. So this is why this kind of automatic shape optimization is done only by companies for whom aerodynamics is strategic. There's a big disincentive to use it. And so within Fortissimo, we'll work on these three aspects. Of course, for the computing resources, we'll use the HPC resources given by our partner Cineca. We implement a standard fault-safe workflow. And maybe the most important thing is that the University of Stuttgart will work on the automatic setup of the optimization procedure. So, you see, the problem of shape optimization is that you're working in often in a very bad scenario. You have typically 5% error bounds on your data, and you have 5% optimization targets. So you don't know really what to do. And at the beginning of optimization, let's say, projects regarding the optimization, you see, this sentence is always said by everyone, that we observe certain errors with respect to our data, but we hope that these errors are constant and that the trends, that means how your functional that you want to optimize behaves with respect to your parameters are conserved. But you don't have any certainty if this is true or not. And so, once you did your optimization, you build the prototype and you test it. If everything went okay, it is great. You have a new product and you have a new methodology which you will use in the future. If not, there's really a big panic because in this case, you dissipated a lot of resources, and for you it is very difficult to even to admit that you learned something. So this is what we want to do within Fortissimo. You see, our big hope in Annalisa is this small, this piece of software here, which is an abstraction layer, which is just in two words. This is just like an artificial intelligence which makes use of the HPC resources in order to set up automatically the whole optimization process. Here are some final remarks. What we would like to see also from the Fortissimo project, it's a clear identification of the end user in order to send out also a clear message. For us, this is crucial. We use a lot of HPC resources, but really a lot, and we need a clear statement about how much will it cost in order to quantify the benefits. And what we would really love, we really appreciate, is if we could find, let's say, a business model which permits us really to abandon in-house hardware and to move completely to the cloud, to the HPC. My very last comment, I know I'm a little bit late, it is about, generally speaking, about this software as a service. I mean, we're all working in order to lower the barriers of order to use these kind of approaches. But it's not only us, there are other people outside who do the same thing. When you lower the barriers of getting in, you lower them also for getting out. Because if you have to buy a cluster and licenses, before changing software vendor, you will think twice because you have to remake up everything. If you have a service, a software as a service, which provides only functionality, and you have two alternative solutions out on the market, you'll test one, but you'll test also the other one. So what we'll believe is that really the quality of the work, of all the software involved, this will make the difference, because a lot of people, a lot of persons are out there which are moving into the same direction. So thank you. I finished my presentation.